Okay. So starting with number 1, and this will actually be number 1 on your test too. It says to classify the segment in each part below, use the information given, and you are classifying like what this segment is. So what is this segment? What is this segment? And what is this segment? So it's vocabulary. On your notes in your chapter 6 notes, it is literally this chart right here. And you can just like match the vocabulary to these here. So just make a note. It's like chapter 6 notes, page 1, and then you can use that to help you if you need it. Okay, so
Say that's the best.
yeah. Like they'll have slightly different questions, but the format, you know what I mean? Like it's on ALEKs, so it'll just give you a variation of this question. So here, this segment right here, it hits at the midpoint of this segment. We know that because this is the same length as this. So this here is a median. And then for the next one, it's describing this segment. This segment hits at the midpoint. It shows that these are the same length on both sides. This also has this little square, meaning it's perpendicular. So this is a perpendicular bisector. Perpendicular, that's the 90-degree angle. Bisector, meaning it bisects the segment in equal parts. Then it says to describe segment RS. This is perpendicular right here. It doesn't say that it bisects that side at all. So this is just an altitude. It's the height of the triangle. Okay, then over here. Again, these start out a little bit challenging. Just kind of stick with it. I'm going to zoom in a little bit more because it's hard to see on here. Okay, so perpendicular bisectors for this one. What I would do is just, or what I'm going to do to kind of show you perpendicular bisector, I'm going to highlight the perpendicular bisectors. So these segments are perpendicular to the sides of the triangle, and they're also like the midpoint of that side. So like this is the same length as this here, same length as this, and this here, same length as this, which might be helpful. And then the other thing that happens with perpendicular bisectors is like these lengths are all the same. So the length from the circumcenter to the corners is all the same. So this length is the same length as this, same length as this. Grab a pencil. Okay, so knowing that, we're gonna look here. It says UV is 48. So I'm gonna make a note that this is 48. PS is 62. So from here to here would be 62. And then RV is 80. And all the red lines are the same length. So if this is 80, then this is 80, and then this is 80. The distance from the circumcenter to the corners is all 80. Okay, and then knowing that, let me see what I need to answer. What is the length of PU? So this length right here. The way I would solve for that is, since this is a right triangle, I can use Pythagorean theorem to solve for that length. To me, this is one of the hardest questions right here, which it gives it to you first. So we're getting it out of the way. So a squared plus b squared equals c squared. So for this is what I'm doing. A squared plus b squared equals c squared. So this would be 48 squared plus b squared, which is what we're solving for, equals c squared, which is 80 here. And then continuing to solve this, 48 squared is 2304 plus b squared, 80 squared is 6400. I'm going to continue solving, subtract 2304 from both sides. B squared equals 4096. Then the last step to get b by itself is take the square root of both sides, and b comes out to 64. So that means that pu is 64 right here. Yes.
Does the navigation number be like 48, 62?
So for this, well, because it's wanting this length, this would be the right triangle, so I need to use those numbers for this right triangle. So this would be A and B. Like those could be interchangeable, but C has to be the longest side. So that would be that. Like I said, this is the hardest one. From here it gets easier. So PR, it's asking for the length of P to R. It shows that this is 62. So then this would have to be 62 since this is a bisector. And then we can just add 62 plus 62 to get 124, and that's PR. So again, easier than that first one. And then QV right here is one of the red lines, which all the red lines are the same length, so that is 80. Okay, so this one was for circumcenter. So just maybe make a note. And then, like in your notes, you have this little chart, perpendicular bisector, circumcenter, and it says the circumcenter is of the triangle is equidistant from the vertices, and it has like a little picture here that you can use to help you. Okay, and then the next one, angle bisectors. Angle bisectors make the incenter, so maybe make a note incenter. And so I'm going to highlight all the angle bisectors. So this is an angle bisector, this is an angle bisector, and this is an angle bisector. And then with it bisecting the angle, like this side of the angle same as this side of the angle same as this, and then this side of the angle is the same as this. And then the incenter is the same distance to each of the sides. So these red lines are all the same length. Okay, so then looking at what they gave us, I'm going to label this UV, right here it would be 22, BV is 23, SAU, so this whole angle right here is 38 degrees, and it says TBV is 54. Okay, so it asks for angle TBS, so that's this whole thing. This is an angle bisector, so if this is 54, this is 54. So TBS would be 54 plus 54 equals 108, and so that would be 108. Then for the length of SV right here, if this is 22, then this is 22 because all the red lines are the same length, so this would be 22. And then for TCV, it wants just this part of that angle. Well, we could figure out this whole thing by just doing 180 degrees minus 38 minus 108 for this angle. And then this would subtract to 34 degrees, but that's like this whole angle. And then to find just this part, 34 divided by 2 would give us just the half. So 17. So this is 17. This is 17. So TCV is 17. Again, we're starting with a challenging one, so just be patient with yourself. Okay, then down here, the last of the harder set, it says the medians. Now medians make the centroid. Medians make the centroid. And the centroid is 2/3 of the distance from each vertex to the midpoint. So I'll show you what that means. So medians, this here, we're going to find the centroid. And the centroid, these segments are in a 2-to-1 ratio. So like each of these medians, so this is a median here. It goes from the corner to the midpoint over here. So like this length is the same length as this. Then here from this to the midpoint over here, and then this would be the same length as this. And then here, and then this here would be the same length as this, if they asked about that. And then these segments are in a 2-to-1 ratio. So like 2 parts to 1 part. And we'll keep that in mind. So it says VU is 10. I'm labeling that. And then if this is 10, since it's in a 2-to-1 ratio, I can just double it to get this length. So it'd be 20. So I just did 10 times 2 to get that. And then VS is 7. So this is 7. And then to get the larger part, I can do times 2 to get 14. So I'm just doubling it. And then it says that PT, so the whole thing for the red is 21. So to find the two parts there, I can do 21 divided by 3 equals 7. And so the smaller one would be 7, one part, and then 2 parts over here would be 14. Okay, and then from here I can answer the questions pretty easily. PV is 14. QV, so from Q to V, 20. And then RS, the whole thing, 7 plus 14 is 21. Okay, now it gets easier from here. Okay, so then over here we have triangle mid-segment. So the mid-segment is parallel to a side. Like this is a mid-segment that corresponds with this. And then this here corresponds with this. And then this would be half of the length of this here. So whatever it's parallel to, it's like half the length of this side opposite it. And then this corresponds with this. Maybe I should use a different color. Here, I'll use blue here so it stands out more. Okay, so then looking at the lengths, it gave us XZ here is 26. So this is a midpoint, so that would be like 13, 13, and then this would be half of that length here, if I need to know that. And then KL is 44, and that's half of this side right here. And then YZ, 78. And again, if I needed this segment, it would be half of 78. So let's see, it wants JK. Okay, so it wants this length here, which is half of this course. Whoa, sorry, I didn't realize my hand was in. This is half of this length. So 78 divided by 2 would give us this length, and that is 39. 39. And then XY. XY, this length right here is double the 44. So just 44 times 2 would be 88. XY is 88. And then it wants JY. Well, this is a midpoint here, so if we do 88 divided by 2, we'd get JY, which is 44. So this would be 44 right here. Okay, and then from here, let's go down to this. For each set, 3 lengths determine if they can be the side lengths of a triangle. So what do we need to know for this? What do we need? We need to know that the sum of the 2 shortest sides must be greater than the longest side. So S plus the medium length side added together has to be bigger than the biggest side. So this would be small, medium, big. So the small plus the medium side has to be greater added up than the biggest side, because otherwise the sides won't reach. Okay, so then looking at these, I'm going to take the 2 shortest sides, which would be 3 and 8. 3 plus 8, is that greater than 15? Well, 3 plus 8 would be 11, and that is not greater than 15, so that would be a no. Here, the 2 shortest sides, 1.7 and 9.1. 1.7 plus 9.1 is that greater than 11.3? If you add those two numbers up, it comes out to 10.8. Let's see, I'm running out of room here. 10.8 is not greater than 11.3, so therefore, nope. And here, the two shortest sides are 7 and 7. 7 plus 7, is that greater than 25? No. And then here, 3 plus 5, the two shortest sides, is that greater than 8? Nope. So it was no for all of them. If it is greater than the third side, then it would be a yes. Then over here, for this one, it wants an inequality to show what the side length x could be. The way to do this is you subtract your two numbers, 17 minus 11, get 6, and you add them. 11 plus 17 would be 28. And so your x has to be in between those two numbers, and the way you set up the inequality is just 6x 28. So x must be greater than 6 and less than 28. It has to be greater than 6 because your two shortest sides have to add up to something bigger than 17. And if it was 6, it would just be 17. And then it can't be more than 28 because, yeah, you have to, like, these sides added up have to be greater than 28. Okay, next. At the back. Again, it gets easier as we go. Okay, for each set of three measures, determine if they are a triangle. So these are angle measures of a triangle. Triangle angles have to equal 180 degrees, exactly. So what you're going to do is just using a calculator, you add up these values and see if they equal 180. If they do equal 180, it's a triangle. If they don't, it's not a triangle. So you just do like 43 plus 33 plus 14 equals 90. No buenos. Nope, because we're looking for 180. You add up these values. It does equal 180 for this one. So that would be yes. Add up these. It comes out to 132. No buenos. Nope. And then add up these. And it does equal 180. So yes. So you're looking for the 180. Okay, next. Over here. Talks about side lengths and how they correspond with angle measure. Order them from least to greatest. I'm going to use the abbreviation small, pequeño, medium, medium, mediano, however you want to think of it, and then big, B for big, grande, grande, large, massive, long, however you want to think of it. Okay. So looking at this would be the smallest side. So opposite that would be the smallest angle. And then this would be the medium side. Opposite that would be the medium angle. And then longest side, opposite that would be the biggest angle. And then it wants least to greatest. So the smallest would be H. Then medium would be I. And then the biggest would be G. Okay, and then building on that, we have the hinge theorem. That's right here, hinge theorem. The hinge theorem says is that if you have two sides equal, then you can compare the third side slash angle. So like you have to have two sides that are equal, and then you can use the third side or third angle to compare the side length. So here for this first one, I see that 29 matches 29, cool. Based on the reflexive property, this side is the same as itself. So then we can use these two angles to determine whether this side is greater or smaller than this one. So 81 is smaller, so this side would be shorter. 93 is bigger, so this side would be bigger. So we can say that WX is greater than WZ. Okay, then here, two sides that are equal, let's see. So this matches this, This matches this. We have two sides that are equal. So then we can use this side to compare the angle. So this is smaller. So then this angle would be smaller. This is bigger. So this angle will be bigger. So angle E is bigger than angle T, or angle T is less than angle E. Okay, next. Let's see, so this matches this, cool. This matches itself. And then we can use this. So this 15 is bigger. So this angle would be bigger, 14 smaller. So this would be smaller. So ABD is bigger, like this. And then what you would choose cannot be determined if two sides did not match, is when you would choose cannot be determined. Okay, and then over here, we have these shapes over here about the polygons. It just wants you to name the polygons. So you're going to name them based on the number of sides. So this has 1, 2, 3, 4, 5, 6, 7, 8 sides. So that is a octagon. This has 1, 2, 3 sides. So this is a triangle. 1, 2, 3, 4, 5, 6 sides. So that is a hexagon. And then we can answer this. Which figure is an octagon? Figure A. Which figure is a pentagon? None. Which figure is a hexagon? C. If you don't know these, you're welcome to write them down. So 3 sides would be a triangle. So you'll be able to use this on the test. So write down all the shapes so that way you can just look based on which shape you get. 4 quadrilateral, 5 sides pentagon, 6 hexagon, 7 heptagon. So write these down so that way you can use them. If no matter what shape you'll get, you'll know what to do. 8 octagon, 9 nonagon, 10 is a decagon, 11 hendecagon, 12 dodecagon, and then after that, it would just be 13 gon, 14 gon, 28 gon. So you just use the number in gon, like that. Okay, so now that you have all those listed out, you shouldn't get that one wrong. You just match. Okay. Then find the sum of the interior angle measures of a convex nonagon. Sum of interior angle measures, we're going to use the equation n minus 2 times 180. So n nonagon is 9 sides. So therefore we put the 9 into this equation. So we get 9 minus 2 times 180. 7 times 180 is 1260. So 1260. Okay, and then building on that, just got that down. It says find the measure of each interior angle and each exterior angle of a regular 18 gon, so 18 sides. And it needs both processes. So we're going to have a section for interior and then a section for exterior. And label it so that way you know which process to do for what. Exterior angles of any polygon add to 360. So you can just take 360 divided by 18 and you'll get each exterior angle, which in this case is 20. That was easy. And then for interior, you have to find the sum of all the interior angles using n minus 2 times 180. And then you divide it by 18 to get each interior angle. So we have 18, so we'll put in 18 minus 2 times 180. 16 times 180 is 2880, and that's for all the angles added up in that shape, but it wants each interior angle, so we have to do 2880 divided by 18 angles, and then each angle is 160 degrees. Okay, and now we're going to do quadrilaterals over here. Right here, it says we have a parallelogram. For a parallelogram, remember, opposite sides are equal. And then also opposite angles are equal. So like this angle is equal to this, and this angle is equal to this, which will come in handy. Let's see. So based on that, I'm going to start with x here. Opposite sides are equal, so therefore 2x equals 8. And then we can solve for x that way. So divide by 2, x equals 4. And then for measure of angle B right here, well, opposite angles are equal. So if this is 70, this is 70 degrees. And then for BCA, this angle right here, remember in a parallelogram, these would be parallel. And so that makes this a transversal. And with that, alternate interior angles are equal. So if this is 48, this is 48. So BCA is 48 degrees. Okay, and then rhombus, last one. For a rhombus, it's a parallelogram. Let me try to draw one. Rhombus, it's a parallelogram. All the sides are equal. The diagonals bisect the angles. So diagonals bisect the angles. And then also opposite angles are equal, which will help as well. Okay, so if the diagonals bisect the angle, if this is 41, then this is 41. And then opposite angles are equal, so this is 41, this is 41. And then for these angles, there's different ways we could do it. And then these will be equal. So let's see. So this angle and this angle are supplementary. So this whole thing would be 82. And then I can do 180 minus 82 to get 98 degrees here. And then this would be 98 degrees. The other way to look at it is you have a triangle. You could do 180 minus 41 to get that as well. And then once you have everything labeled, angle 1, 98, angle 2, 41, angle 3, 98, and angle 4, 41. Okay, that's it all. So now your to-do list is to do the practice test on ALEKs. So chapter 6, 7 practice test on ALEKs. Grab a computer, see how much you can get done before the end of class, and then finish it up for work. Yes, ma'am. Thank you for being patient.